All right. What are some forms of energy we've talked about in class? Kinetic, thermal, chemical, potential, and one that was not wrote down, but we did talk about. Starts with an N. It does give off radiation, yes. Nuclear. That's right. Okay. So one of the things that's unique about nuclear energy is it's really efficient and it's extremely long lasting. But when things go wrong, they really go wrong. Way long ago before your time. There's a place called Chernobyl, Russia. Okay? And that was 1983. Okay? One of the things that happens with nuclear energy is I believe the process is there's rods of uranium, okay, that once they become superheated, if you want to call that, one of the things that happens is as water is heated up that we've seen with Jay Leno's vehicle. What was Jay Leno driving around? Two types of what? Cars. Specifically, what types of cars, though? Say that again. Steam-powered cars, okay? But with nuclear energy is way more efficient and it lasts a long time because of this element known as uranium. But what had happened in Chernobyl is that the heating rods, they have to sit in a cooling tank or water needs to come in and continually replenish that to cool them down. I believe that malfunctioned to some certain extent, and that what had happened is the uranium rods became superheated or super hot, if you want to call it that. And then what happens is the reaction that causes these atoms to split with these uranium rods, because uranium is radioactive, okay, was way too violent to actually be encased in the building. And I want to say they're probably still picking up radiation over in Russia. This is 40 years ago.
Yeah, it was bad.
Okay? Lots of people died. So when something like that happens, I think everyone agrees nuclear energy is the way to go. But just don't put a reactor in our community. I think that's probably pretty common for someone to say. Now, the reason we can use an analogy that'll make more sense to you that has been in the news since before Thanksgiving. Okay? Where is South Dakota's state correctional facility?
Here.
No.
No, isn't it in Sioux Falls?
It's in Sioux Falls. Actually sits on top of the hill of Sioux Falls and overlooks Falls Park.
Is that the light place?
Yeah, Falls Park is the light place. Okay, so what happens with that is I don't even know how old that prison is. I want to say it's probably over 100 years old.
Yeah.
Okay?
Yeah.
So the building is old, it's inadequate, it's not cost efficient, and it's not big enough for really bad combinations. So what has happened is the state has land south of Harrisburg and says, okay, we need a new correction facility. The state agrees we need to have this correction facility, so we're going to put it south of Harrisburg. And I think Harrisburg says, no, you wait a minute here. We know we need a new correction facility, but don't put it in our community. Put it in okay. Yeah, I mean, okay, I'm not saying that that's wrong, and that would be a possible solution, but how many of you as citizen law-abiding citizens would say, we know we need this, but don't put that just down the road in Moody County.
Put it like out in the middle of nowhere.
That's kind of like what it would be in Harrisburg. There's really not a, it's, when we say Harrisburg, that's just a place to make a correlation to. Like when we say Tri-Valley, what does Tri-Valley mean to you? It's a high school.
In the middle of nowhere, boys.
Right, it has an actual address of Colton, I believe.
Grand Meadows, South Dakota.
Okay? So when we say Harrisburg, that just gives you a place where it's located. Okay? So the same thing with nuclear power. We'd probably agree that it's the way to go, but just don't put it in our location. Okay. So the two main types of energy we want to be concerned about are kinetic and potential. What is the difference between the two? What is the difference between potential and kinetic?
Potential has like, oh, where'd they go?
Kinetic is moving, and you're right, but why are you right? How did you know that? You're not wrong. You didn't answer. How did you know that's right? Because what does kinetic energy have that potential does not? We're actually pointing up to the board. It tells you that.
Increase in mass as it moves.
He's not asking for
Close.
kinetic energy.
Close. What does...
Energy in the form of motion.
Well, right, but that still doesn't answer the question. There's something missing in the potential energy formula that is present in the kinetic energy formula. And when we tell you, you're going to say, I knew that.
Velocity.
Yeah, velocity is present. If something has velocity, that means it's moving. That's a major difference, okay? What two things do potential and kinetic energy have in common then? True. True. What are they measured in? Joules, okay? And then what other variable do they have in common? They both have mass. That's right. Okay. So, moving forward then. So, I don't think we wrote this down, did we? Okay? So, if energy is stored, the main idea behind that is it is not moving. Okay? So, what happens when you stretch? There's a lot. There's probably snap right back in my face because it's an old rubber band. But what happens, you pull it back and, oh, there it went. Okay? So you pull it. Okay, I'm not going to pull it as hard. Okay? Once you reach this stage, is it moving? But there's lots of stored energy in there because once you let it go, well then, okay, all that goes back to its original state. That gives it lots of energy. Okay. So one of the aspects you had correctly, that we correctly addressed was, okay, stored energy means it is not moving. So what three variables make up your potential energy formula? We said mass was one, gravity is another, and distance or height would be your third one. Okay? Sure, now I can, oh, there it went. You say now I can pull on it, it doesn't break. But, all right. There's an addition over there in today's block. It says assign worksheet chapter 4 due on Thursday. But it also says and vocabulary. That's due on Thursday as well. Now keep in mind there's probably what? 7 vocabulary terms. Okay? So those are also due on Thursday. We'll do a vocabulary quiz next week. Typically The days that these are due is when we have an evaluation. But I don't want to go back to back with that. Because next week, we want to get started on your Hidden Figures project. Okay. Okay. So when we look at what we want to call the first types of lights to ever be invented, which was made by what two? Notice I said which inventor. One's accredited for it, but there's also another one that invented a light bulb. No, it was actually before Albert Einstein.
What's his name?
That's what I'm asking.
Something with an A, right?
It's an A in his last name, yes.
There's an A.
Abraham Lincoln?
Albert Einstein.
No, we said that already. When I tell you, you're going to say, I knew that.
Benjamin Franklin?
Not that far back.
What's his name? What is
Tom something. Thomas Edison did the iridescent light. But there's also another inventor that's not as well known. And it's also a type of car. It's this one right here. A Tesla. Nikola Tesla also invented a different type of bulb. Okay? But for the most part, okay, we just have a job to do. Let's get this wrapped up. You all right?
Me?
Yes.
Yeah, fine.
Okay. It didn't look like it. I just. All right.
Is that Mr. McKenna?
Sure.
You're supposed to say I'm God for real.
Must be a generational thing. All right. So, what happens in the very first set of light bulbs? Electrical energy is shot through a nichrome wire. That could be looking at. Tungsten. No, it's tungsten. The metal is tungsten. Okay? And then when that happens, it gets really, really hot and it gives off heat. Okay? Okay? All right. So in this case, here's, we can be really, really mean here if we wanted to and say, what are the two types of engines that run on different fuels?
Diesel and gas.
Diesel and gas. Okay? So, the mechanism and how they work is quite different. Okay, when we see this. A spark ignites chemical potential energy is converted to thermal energy, which is then converted to kinetic energy. Is that a gasoline engine or a diesel engine? Why does it have to be you're right, but why does it have to be a gas engine?
Diesels don't need
Oh my gosh, Ron.
Okay? So then, but when we look at this, gas is a really vague term. Okay? But in this case, yes, that's true. Because when we talk about gases, they could be carbon dioxide, that's a gas. Hydrogens, that's a gas. Okay? Diesel in this case, yes, it's a fuel, but when you put it into a mist type of form, that's also a gas type of aerosol. But the difference between these two is, if my interpretation of this is correct, so some of you who know more about motors / engines maybe than myself, which doesn't take a whole lot, but what happens in a diesel engine, that diesel gets placed into the cylinder, comes up and compresses that fuel into a really small area, and when that gets compressed into there, it ignites. Okay? That's different than an octane / gasoline engine where a spark has to ignite that. Okay? That's the difference between, one of the major differences between diesel and gas engines. That's why there's a distributor cap in gasoline engines. That distributor is hooked up to your maybe 4 spark plugs if it's a slant 4, or 6 if it's a V6. But the most common type of engine is called a V8. Okay? So then when you say V8, it has 8 what in it? There's 2 ways you can look at it. The block looks like this, okay? And it's got 4 cylinders on this side and 4 cylinders on this side. Hence 8 valves, so that's what makes it a V8 engine. Okay? Make sense? Well, it's not supposed to make sense, but it's just how things work. I don't know. Hopefully it makes sense to yourself now. Okay, we don't have a whole lot left. Want to do this one, that one. Holy cow, there's more left than I thought. Okay. I think, okay. So, one of the things for deer hunting, okay, how many bow hunters do we have out here in the audience? Is that rifle or bow? Oh, both, okay. So one of the things that, thanks to technology, okay, early bow hunting was, yes, you have a simple machine, you pull it back, and it might have been kind of difficult to hold that in one spot. But now, bow and arrows are way more complex. They give off a lot more energy because it has a different name in it. Does anyone know what it might be? It's got lots. No. It's got lots of, maybe, if you want to call them gears or pulleys on the top and the bottom. Say that again? A compound bow. That's right. Okay? So one of the things that happens is, as, again, you pull that string back and you hold it, that arrow, is that potential or kinetic energy? We're doing this. What type of energy is this? Why is this potential energy? Because what? Right, because it's stored. It's stored in that bow. Once you let go, that string thrusts forward and pushes that arrow along. So that stored energy is then moving forward. When we're talking about mechanical energy, that is kinetic and potential put together. Okay? So I think the best way to explain this, okay, is a grandfather clock. Okay? What is it that causes the mechanism to turn in a grandfather clock? It's called a pendulum, but what is a pendulum? Does anybody know? How could this resemble a pendulum? Okay? Does it do this? No, this isn't correct. Does it what way?
Goes like this. Like this.
How about we do that? Okay?
A pendulum.
This is a pendulum. Okay? So if you've ever seen a grandfather clock, this is what happens. So, how is this both kinetic and potential? Well, what happens is, okay, when that pendulum gets all the way to one side, it stops for just one moment, okay? So that is where the potential energy is the greatest. Because then, when it goes back the other way, okay, then it goes back to this side. And goes from 0, increases all the way to the other side, back to 0, then back and forth like this. Okay? So, how does this pendulum know to keep going? What tells it to do that? It's where you open up the door, and there's 3 types of brass something inside of there. We call counterweights. Okay? Have you ever seen maybe your one of your grandparents or great-grandparents, if they're still alive, okay? What happens, they open up the door, that brass weight is all the way at the bottom. Once all 3 of them get down to the bottom, the pendulum will stop. Why is that? Because it's out of energy. So then what happens, you pull that, pull the chain, the weight goes back up to the top, and then that stored energy then is slowly let down by those 3 weights, which causes your pendulum to keep track of time. Grandfather clocks is a good example of how mechanical energy works, because it's a constant conversion of this. The position and the motion of this object or pendulum is how this works. Okay. Okay, we're almost done taking notes for the entire semester.
The first one isn't on our
That isn't on there. Yeah.
the second one is, but
Well, you just have to write this in then. It's usually a misconception that we say this early scientist discovered gravity.
Newton.
Yeah. Also the inventor of calculus, okay? Or father of calculus. Newtonian math. But it's not so much it was just apparent that to him. So just out of curiosity, if you know the scientist, do you know approximately when that was? I don't know why you would know that. I just felt like asking. I want to say 1620s. Okay? So in the early 17th century, I believe is when Sir Isaac Newton was alive. And it's not that he discovered gravity. Just figured, well, something must be causing things to fall. And with that, just said, we're going to call it gravity. Okay, so at the peak of a path, it doesn't say what type of object it is, but think of this pendulum again, okay? At the peak of the path, the kinetic energy is low. So at the peak, why is this potential energy so high and kinetic energy is low? Because what's it going to eventually do when it gets all the way to the top? But in order to do that, it's not accelerating, it's what? Say that again? Close. It's decelerating. So it slows down and comes to a stop right here. That's where it has the greatest amount of potential energy and the lowest amount of kinetic energy, because if it has a velocity of 0, how much energy is that? 0. Any number times 0 gives you 0. And that's what this is saying. At the peak of the path, or on this pendulum, on either side, at that peak, that is where the kinetic energy is the lowest and the potential energy is the highest. Is there any Edgar Allan Poe fans in here? Who's Edgar Allan Poe? Anybody know? He's an author. I think he has. Okay. So in an odd twist, there is an NFL mascot named Poe. How did you know that? That's right. How did you know that? But okay, so that answers. Okay, so Baltimore's mascot is the Ravens. So how do you connect Edgar Allan Poe with the Baltimore Ravens? He wrote a book or a short story called The what? The Raven. And that's why Baltimore has its mascot named the way it is, Poe. Okay? There's different types of, I think the monkey's paw was another one, the cask of Amontillado was another one that involves a pendulum. Okay? So, moving forward, 1, 2, okay. Almost there. So then, why is the kinetic energy so high right here? Because when the potential energy was really high here, the kinetic energy was low. Now, as the pendulum swings back down, okay, why is the kinetic energy the highest here? Because this is where it's moving the fastest. Because as we said, moving from one side to the other, at one side of this pendulum swing, it's decelerating, which means that value is approaching what? 0. That's why. Okay? So then, on a swing set, okay, that's kinetic energy, and we say that this energy can't be destroyed. Well, it's not. But one thing to keep in mind is that as that swing set is going back and forth like this, kind of like a pendulum, it doesn't have a counterweight pulling on that. But up on the eye hooks of that chain, what happens between the chain hook and the eye hook when two objects come in contact with one another? What's this called? Friction. And friction gives off what? Right. So what we see happening here, this energy is not destroyed, it's just transferred to heat. Okay? All right. So the last thing we'll do for note-taking for this semester, brace yourself.
Yes.
Yay! Is right here. Okay? So on a swing, you begin to slow down if no one pushes you. The energy is not being destroyed, it's just being transferred into those eye hooks. And that transfer is due to friction, and that friction is a type of thermal energy. So here in a few moments, what is happening on Thursday in this class? True.
All caps do.
And you're right. What else?
This paper.
Your papers also do. All right.
Thursday 7th.
Okay. See, now you won't look at who has grandparents that have a clock working like this.
Not my grandparents. My grandparents.
Okay? You'll never look at it the same. Just like last hour, we were talking to the lady basketball players, because some of them are farmers. Some of them are farmers. Talking about different types of hormones, which is important to an agriculture producer, but we also talk about how hormones work on the farm. Okay. Does everyone have this content that wants it? It just helps me explain the content to you. Okay, so we can shut this off. All right. Just like every other problem, what is the best thing that you can do for yourself? Right. Whether it's the mass, if it's potential energy, it's not going to tell you this every time. What variable do you have to know in potential energy? Say that again. Gravity. It's not going to say gravity or acceleration or anything like that. You have to know that if it's stored energy, gravity is acting upon it. All right. So you have the rest of the time to work on these, and we will review for your problem evaluation tomorrow and Thursday. Your evaluation is on Friday. Your vocabulary is due on Thursday as well. All right. We'll catch up to you next time.